Hello guys and welcome to a new video in physics. In this video, we will talk about the angular momentum. Newton's second law for rotational motion, torque equal to I delta omega over delta t. This is the second law for rotational motion for Newton. This equation states that angular velocity of a rotating object changes only if torque is applied to it. This equation can be rearranged in the same way as Newton's second law of motion was to produce torque delta T equal to I delta omega. This equation is exactly the same to this equation. The left side of the equation is the angular impulse of the rotating object. The left side, which is torque delta T, that represent the angular impulse of the rotating object. And the right side of the equation, which is I delta omega, that can be written as I omega f minus I omega initial. The angular momentum of an object is equal to the product of a rotating object's moment of inertia and angular velocity. This is the definition of angular momentum. So the angular momentum of an object is equal to the product of a rotating object's moment of inertia and angular velocity. The symbol of the angular momentum is L. So L equal to, from the definition, we said that equal to product of a rotating object's moment of inertia. So this is the moment of inertia, which is I. And angular velocity that's meaning delta omega. So angular momentum L equal to I delta omega. Angular momentum is measured in kilogram meter square over second. This is the unit of angular momentum. As you can see here, I delta omega that's represent the right side of the general equation. Just as the linear momentum of an object changes when an impulse acts on it, the angular momentum of an object changes when an angular impulse acts on it. So in previous video, we said that the linear moment of an object changes when an impulse acts on it. Here also, the angular momentum of an object changes when an angular impulse acts on it. Thus, the angular impulse on the object is equal to the change in the object's angular momentum, which is called angular impulse angular momentum theorem. And here we have the general equation for the angular impulse angular momentum theorem, which is torque delta t represent the time, equal to L final, which is the angular momentum final, minus the angular momentum initial, which is L initial. If there are no forces acting on an object, its linear momentum is constant. If there are no torques acting on an object, so its angular momentum is constant also. Because an object's mass cannot be changed if its moment is constant, then its velocity is also constant. Because an object's mass cannot be changed if its moment is constant, then its velocity is also constant. What does that mean? If you remember that we had a law which is I equal to mv. I that represent the momentum, and m we have the mass, and velocity, this is v. So if we have that I is constant, and also we have the mass is constant. So of course that the velocity will be constant also. That's the meaning of this note. The angular velocity of an object can change, however, even if no torques are acting on it. This is because the moment of inertia depends on the object's mass and the way it's distributed about the axis of rotation. What does that mean? Here we have, for example, a diver can control her angular velocity by changing her moment of inertia. So you can see her shape just like this, and after that like this or like this. So this is the diver can control her angular velocity by changing her moment of inertia. So the velocity is changing depending on the moment of inertia. Here we have an example. A DVD I equal to that's moment of inertia equal to 2.7 times 10 to power minus 5 kilogram meter square. Rotates at 25.5 rotations per second when the inner edge is being read, and at 10.5 rotations per second when the outer edge is being read. What is the change in angular momentum as the disk is read from the inner edge to the outer edge? That is our example, and as we learned in the beginning, we will write the known and the unknown from the question. So from the question, we had I, which is moment of inertia, equal to 2.7 times 10 to power minus 5 kilogram meter square. This is the I. And after that, rotates at 25.5 rotations per second when the inner edge is being read. So here we have the angular velocity initial. Here we have omega initial equal to 25.5 rotations per second. And after that, and at 10.5 rotations per second when the outer edge is being read. So we have the omega final equal to 10.5 rotations per second. What is the change in angular momentum? We need to calculate the angular momentum. So delta L, this is the unknown in this question. So to calculate delta L, in the beginning, we should find L initial and L final. So just like this, we can see here, sorry for this, it should be L initial equal to I equal to I omega initial. This is the law, L initial equal to I omega initial. So 2.7 times 10 to power minus 5 multiplied by 2 pi multiplied by 25.5. Here we have 2 pi because we should convert the unit from the rotations to the rad. So we multiplied the number by 2 pi. The result will be 0.0043 kilogram meter square over second. Here we have also the law should be L final equal to I omega final. So we have the moment of inertia that's equal to 2.7 times 10 to power minus 5 multiplied by, also here we have 2 pi, and as we said, we should convert the units from rotation, here we have from the rotations to the rad. So we multiply the number by 2 pi. 2 pi multiplied by 10.5. The result will be 0.0018 kilogram meter square per second. Now we found L initial and L final. In the question, he asked me to find the angular momentum. So angular momentum which is delta L equal to L final minus L initial. L final, here we have it, which is 0.0018 minus 0.0043 kilogram meter square over second, which is L initial. The final result will be minus 0.0025 kilogram meter square over second. This is the change in angular momentum, which is delta L. Now we reached to the end of the lesson, and here we have some questions about the lesson, so please solve it and send it to me. The first question that we have about this lesson is, which are the units of the momentum? By the way, this is for this lecture and the previous lecture, so this is about the whole lesson. Which are the units for momentum? Choose one of them. Which has the greatest moment from them? This is the question number 2. Question number 3. Which is the product of a rotating object's moment of inertia and angular velocity? Which one is the right one? This is a definition, so the definition of what? Or you can say this is a law, so the law of what one of them? Which is represented by the following equation, F delta T equal to Pf minus P initial. This is the law of what? And the final question here, which is represented by the following equation, L equal to I omega. Which one of them that's represented by this law? Until here, we reached to the end of our video. See you soon in another one, inshallah.